Hello everyone, welcome back to our Arduino course. Today I'm going to show you how can we read data in Arduino, and I will use the push button to do that. Let's start. What is push button? Push button is a device that can open or close the circuit temporarily. It has a spring to return the switch to its default position. Here is the electric symbol. It has 2 pins. The current cannot go through this push button if the button is not pressed. When we press the button, the current can go through it. It can pass from this side to the other side. Here is the real push button, how it looks in the reality. It has 4 pins. Here in the demo we can see it has 4 pins. There is 2 pins. Each 2 pins are connected together. This side, these 2 pins are connected together, and in the corresponding side, these 2 pins are connected together. So how can we connect this push button to the circuit? We have to connect it from the unconnected pins. So we have to connect the push button from this side, this pin and this pin, or from this side. Here is the push button. It has 4 pins, as you can see. I'm going to show you how can we identify the connected pins and how can we connect this push button to the circuit. First of all, you should have avometer. Just set the avometer on Wi-Fi and let's test it. We test this pin and the other one here. You see it gives alarm. So these 2 pins, this and this, are connected together. Let me test the other side, which is this one and this. They are also connected together, these 2 pins. If we check these 2 pins, this one and this, you see, they are not connected. They will be connected if we press the push button. I will press it now. Okay, let me just, you see, now there is an alarm because I pressed the push button. Let me release my finger. There is no sound. So these 2 pins are connected together, and these 2 from the other side, this one and this one, are connected too. So what I'm going to do, I have to connect my circuit between these 2 pins, this one and this one, the unconnected pins. And here too, we can connect them also from the other side, here and here, in these 2 pins, unconnected. Don't connect your push button on the connected pins. You have to connect your push button on the unconnected pins. Here we have example. We have 2 circuits. Here is the first one and this is the second one. Let's start with the first circuit. We have 5 volt, which is the positive of the battery, push button, resistor with 10K resistance, and GND, which is the negative of the battery. This is test point. We are measuring the voltage in this node. So normally the voltage is in this node is 0 volt. As you can see, this point is connected to GND and the circuit is opened because the push button is not pressed yet. So normally the voltage in this point is GND. When we press the push button, the voltage, it changes to 5 volt. So we say the circuit normally is open and the voltage in the node is 0 volt. If we push the button, the circuit is closed and the voltage in this point is 5 volt. The second circuit, we have 5 volt resistor, push button, and the GND. And test point number 2, the voltage in this point is normally 5 volts. So look, it's connected to 5 volt and the circuit is open here. We didn't press the switch yet. So the voltage, we say the voltage normally is 5 volt here in the node, and when we press the push button, it changes to 0 volt. So when we press the push button, this point it will be connected to the GND. So the voltage it changes to 0 volt. So we say in the second circuit, the circuit is open and the voltage is 5 volt in this node, and if we press the push button, the circuit is closed and the voltage it changes to 0 volt. What is going to happen if we remove this 10k or 10 kilo ohm resistor? Why we need this resistor? So as you can see, if we removed this resistors, it's going to happen short circuit. So imagine this circuit without this resistor. Imagine it's like a wire here. So when we press the push button, we are connecting the 5 volt to GND. So positive connected to negative. So explosion will happen, or short circuit we call it. Same here in the second circuit. As you see, this chicken, when you press the button, boom. So we need this resistor. I will show you here in the demo. We have in the first one with resistors, with the 10k resistor, and here without the resistor. As you can see here, in the first circuit, we have the voltage in the node is 0 volt. When we press the button, it changes to 5 volt. Second circuit, normally 5 volt. When we press the button, it changes to 0 volt. And here in this demo, we don't have resistors. As you can see, when we press the push button, short circuits, it's explosion. So we need this 10k resistor. Here I simulated the two circuits. The first one, 5 volt connected to switch connected to resistor to GND. And here I have voltmeter or multimeter. I connected between the point which I'm going to measure the voltage and GND. And here I have LED with resistor just for showing. Now the voltage in this point or this node is 0 volt. If I press now the switch, it changes to 5 volt and the LED is on. In the second circuit, 5 volt to resistor to push button to GND, and we have voltmeter. Now normally the voltage in this point is 5 volt. If I press the switch, it changes to 0 volt, as you can see here. Here we have our schemes, Arduino schemes. Here is the first scheme. I'm going to connect the push button in this way. 5 volt to push button and push button to resistor, and from the resistor to GND. And I connect this node to pin number 2, and as you can see here, the LED is connected to pin number 3. Here normally the voltage in this point is GND, it's connected to GND, and push button is open. Here you can imagine it like open circuit here. So the voltage in this point is 0 volt. It's connected to GND. When we press the push button, the voltage will be changed to 5 volt. What I'm going to do in Arduino, I will write a code. When I press the push button, I will let the LED on. When I release my finger from the push button, the LED will be off. This is what I'm going to do in my code. As I said, this is the first scheme, and it's same the first circuit. I connected 5 volt to push button to resistor, resistor to GND, and I connected this node to pin number 2. You can imagine this point as pin number 2 in Arduino. Here is the code for the first circuit which I showed you. I defined a variable. This is data type Boolean. It takes true and false because the state is 0 and 1, high and low, which is coming from the node. 5 volt or 0 volt, 2 states. That's why I define it as Boolean, and you can define it as integer or any data type, but here I decided to define it as Boolean. As I said, push button data with value 0. Define button 2. This is for pin number 2. I defined another variable. I called it button for pin number 2, which is this one. I called it button. And pin number 3, I called this variable LED. So in void setup, here we have 2 instructions. The first one is for pin number 2, pin mode button, which is number 2, pin number 2 as input. I defined the pin number 2 as input because I'm reading data from the push button. And in the second instruction, pin mode LED output, which is pin mode, pin number 3 as output. Why? Because here I'm going to write data. I'm going to write data. As I said, pin number 2 reading, because I'm reading data from the push button, and pin number 3 I'm going to write on this pin because I want the LED to be on or off. Here the process is writing, not reading on pin number 3. On pin number 2 it's reading because I'm reading data from the push button. In void loop, push button data equal digital read button. Here I'm reading the data, this instruction for reading data from the push button. Here digital read, it means reading data on the pin number 2, which is coming from the node. Digital read button, it means pin number 2, here pin number, and I save the data which is coming from pin number 2 in this variable push button data. Here I have if else, if push button equal high, digital write LED high. Here LED is on. Else digital write LED low. Here LED is off. If push button data equal high, it means the push button pressed when this node will be 5 volts high. It means the state of this node or the voltage on this node is 5 volt. It becomes 5 volt when I press the push button. So here, if the push button is pressed, equal high, it means if the push button is pressed, digital write LED high, LED is on. Else, if push, it means what is else? Else it means push button equal low. So it means when I release my finger from the push button, digital write LED low. Here is our first circuit. We connected the 5 volt to the switch and the switch to resistor 10K, and from the resistor to GND of Arduino. And the node which is between the resistor and the push button, which is this green wire, is connected to pin number 2 in Arduino. And LED, I connected the LED to pin number 3. So let's test the circuit. I will press the push button now. As you can see, it works. When I press, the LED is on. When I release my finger, it's off. Here is the second scheme. The second scheme, I connected 5 volt to resistor, resistor to push button to GND, and this node I connected to pin number 2, and same LED to pin number 3. Here it's same the circuit number 2, which is this one. 5 volt to resistor, resistor to switch, switch to GND, and this test point number 2, it's pin number 2, as you can see here. So normally the voltage in this point is 5 volt because it's connected to 5 volt, and here the circuit is open. And when I press the push button, the voltage in this point, it will be changed to GND. It means 0 volt. What is the changes in the code? It's same code, but here in the if else, I just changed just if push button data equal low. I didn't say high. In the previous one I said high. Why low? Because when I press the push button here, the state of or the voltage on this node, it will be 0 volt. So I said here, if push button is pressed, it means low. Digital write LED high, LED is on. Else, if I release my finger, the state or the voltage on this node, it will be 5 volt. So I say digital write LED low, it means LED is off. So we just here change in the second circuit, we change this to low. And here is the second circuit, which is I connected this pin to 5 volt, 5 volt connected to the resistor, and resistor connected to the push button, and the other side from the push button is connected to GND, and the green wire which is connected between the resistor and the push button, the node, is connected to pin number 2, and the LED as before on pin number 3. So let's test. As you can see, it works. And in the last scheme, which is third one, I'm going to connect the pin number 2 to the push button, and from the push button to GND. But here I enabled in the code the pull-up resistor. What is pull-up resistor? It's this circuit, which is 5 volt connected to resistor, and resistor connected to pin number 2. This pull-up resistor is already integrated in Arduino board. So when we say in our code input pull up, it means this pull up resistor is enabled, and you can imagine it as you can see here. So 5 volt to resistor, and resistor connected to pin number 2, and I connected this pin number 2 to push button connected to GND. So it's same the second circuit, but here we are not going to use external resistor, which is 10k ohm. Here we are going to use the internal one, which is pull up resistor. Just all what you have to do, just say in your code input pull up. I'm going to explain it in the code. So let's go to the code. Before going to the code, I just want to say the voltage normally in this point is 5 volt, and when we press the push button, it will it changes to 0 volt, and it's same in the second circuit, which is this one. But I'm not going to use, as I said, the 10k ohm resistor, because I'm going to use the internal one, which is pull up resistor. Let's go to the code. Input pull up, just type input pull up, and this resistor automatically will be enabled. It's almost same code. Here it's same, the second circuit, push button data equal low, the LED is on, else digital LED low, LED is off. It's same, just we don't use external resistor here because it's already integrated in Arduino. Let's go to the practical now. Here is a third circuit with the pull-up resistor is enabled. As you can see here, I connected the pin number 2 to push button, and the other pin of the push button is connected to GND, which is this one. This is pin number 2, and this is going to GND. As you can see here, the external resistor is removed. I removed the external resistor 10k because I already enabled the pull-up resistor, which is already integrated with Arduino. And here we have the LED, which is already connected to pin number 3. Let's test it. As you can see, it works. So normally, as I said, normally it's 5 volt. Now when I press, it will be 0 volt. LED is on off. See you in the next video. Bye for now.